Good morning from Cape Canaveral Air Force Station in Florida, where the SpaceX Crew Dragon, poised on Space Launch Complex 40, is set to take flight for the first time during what is called a pad abort test. This test will not have any crew members aboard the spacecraft, but it will simulate an emergency escape from the launch pad in the unlikely case of a booster failing at liftoff or another scenario that would threaten astronauts inside the spacecraft. We're about 24 minutes, 12 seconds away from the test. Everything is on schedule for T0 at 9 a.m. Eastern Time. This test will see the Crew Dragon spacecraft and trunk, together about 20 feet tall, fly on the power of 8 Super Draco engines. These hypergolic-fueled Super Dracos each produce 15,000 pounds of thrust, and they're expected to burn for about 6 seconds and lift the spacecraft about 5,000 feet above the launch pad before it parachutes into the Atlantic Ocean about a mile offshore from the launch pad. And the test will last only about a minute and a half. That's what you would expect, because SpaceX is trying to show just how fast it can get astronauts away from a dangerous situation. Here's a video of a demonstration of a pad abort profile with 2 engines, with 2 Super Draco engines that were fired recently at the Texas McGregor facility, the rocket development facility of SpaceX. And that will give you some idea of what awaits us in about 22 minutes, 40 seconds from now. Weather forecasters from the U.S. Air Force 45th Weather Squadron continue to predict a 70% chance of favorable weather during the test. Right now, there are no launch commit criteria issues. Everything is go. There is a tropical low in the vicinity, but it continues to move off to the north. And as the day progresses, should there be a need, we expect that the low will pull away and all the weather will get even better than it is right now. But again, right now, we're completely go, no issues whatsoever. We're at T-minus 21 minutes, 56 seconds, and counting. This is Dragon Test Control. This is Dragon Test Control at T-minus 20 minutes, 7 seconds and counting. And everything is go. Dragon is powered up. There are no weather concerns. Everything is looking very good. And we're very pleased right now to be joined by Eric Boe, NASA astronaut, who's been an astronaut since 2000 and a veteran of 2 space shuttle flights. Welcome, Eric.
Thank you. It's good to be here, Mike.
Thank you for taking time to be with us today. This is a milestone day for the Commercial Crew Program and for NASA as we move forward in our campaign, I guess, to return launches to American soil, U.S. astronauts going up to the space station. Can you tell us a little bit about why you're here today and what this means to you?
Well, you're here to, this is, as you said, the kind of some of the initial testing that we're getting started. We're getting to the hardware phase, before we've been doing a lot of engineering over the last few years. And these companies, SpaceX has been working on this. And so this is one of the first big tests, as we move forward with the chance to put humans back into space from Florida.
So from an astronaut's perspective, how important is the ability to have a crew rescue capability?
It's a great capability. It's one of the things the shuttle didn't have, where you can actually be on the pad, and essentially it's kind of like an ejection seat is in an airplane. You have the ability to leave the pad sitting in the capsule, and the capsule would come off and land. So it's a great capability, and of course, flight test is an important part of this to make sure we have the engineering models, but you really need the flight test to verify the things that you've done, figured out, looked at analytically. So
with this test, if all goes well today, we'll be one step closer to getting to fly again. You looking forward to returning to space?
Absolutely. It'd be a great thing. I'd love to fly one of these vehicles, one of the commercial crew vehicles coming up. It'll be nice to start launching again from Florida. As you know now, our crews are launching out of Kazakhstan on the Soyuz, so it'll be nice to be flying on U.S. space vehicles again.
Well, we're looking forward to it, and really appreciate you dropping by today.
Absolutely. Glad to do it.
Okay. Thank you, Eric.
Have a good day.
This is Dragon Test Control at T-minus 17 minutes, 8 seconds, and counting. NASA's spaceflight specialists have been working with SpaceX throughout the design of the Crew Dragon and will be analyzing the results of the flight test along with SpaceX. The results will be used to help inform a host of computer models and plans before the spacecraft's final version moves into production. Today, there are about a half dozen NASA managers with the SpaceX team in the Launch Control Center in Cape Canaveral, Florida, including the Commercial Crew Program's Kathy Leaders and the Associate Administrator for Human Exploration and Operations, Bill Gerstenmaier. And another handful of NASA representatives are here in the Launch Vehicle Data Center at Cape Canaveral Air Force Station's Hangar AE, including engineers who have been working with SpaceX on the development of the Crew Dragon and the Falcon 9 rocket since 2012, as well as Eric Bowe and 4 or 5 other members of NASA's astronaut corps. The teams want to see how the Crew Dragon's 8 engines interact together, how fast they can lift the 8-ton spacecraft off the launch pad, and what kind of acceleration the Abort system would place on the astronauts. Inside the Crew Dragon, the Abort system is integrated into the side of the spacecraft instead of on top, which has happened with previous spacecraft. The ability to lift the astronauts and crew members out of harm's way is vital for the next generation of piloted spacecraft, and that's why NASA certification contracts include the Abort capability requirements. This is an important step in returning launches to U.S. soil, and it fits right into NASA's journey to Mars, launching astronauts to the International Space Station, where the one-year mission is underway. The ISS is NASA's key to exploration, and it really is the linchpin connecting the Commercial Crew Program with the ability to launch astronauts to the station with our future exploration goals and the journey to Mars. We're about a minute and a half away from the clear to launch poll that will be conducted by SpaceX launch conductor Aaron Beck. She and launch director Kiko Donchev are overseeing all the operations today and will be standing by for that poll at T-minus 13 minutes. We're at T-minus 14 minutes, 18 seconds, and counting. This is Dragon Test Control. This is Dragon Test Control at T-minus 13 minutes, 10 seconds, and counting. Standing by for a poll for a go for launch from launch conductor Aaron Beck.
All stations, go for terminal count, beginning with mission assurance.
Mission assurance is go.
DC.
DC is go for terminal count.
GC.
GC is go.
SIS-1.
SIS-1 is go.
SIS-2.
SIS-2 is go.
CC.
CC go.
NAV.
NAV is go.
Flight software.
Flight software go.
Mission software.
Mission software is go.
IT.
IT is go.
Recovery.
Recovery go.
RC.
RC go.
OSM.
OSM go.
ROC.
ROC is go.
LD.
LD is go pending that we resolve our range weather field mill rule here, and we don't violate it in the near term.
Copy. LC is go. DC, you are go to enable the terminal count auto sequence. If a no-go is required, we will call within the time to protect, T-minus 3 minutes, 30 seconds.
All stations, terminal count auto sequence is enabled.
T-minus 12 minutes and counting, and as you heard from the poll, all stations are go. At this time, there are no weather constraints. There is a cell that is moving into the vicinity of the launch pad from the northeast as part of this low-pressure system. As it moves closer, it is dissipating. It is not expected to produce any rain, but it is potentially able to trigger the electrical field mill instruments in the area. But as of right now, everything is go. The Crew Dragon spacecraft has been outfitted with 270 sensors and will be carrying a human-sized test dummy inside. The sensors will measure acceleration and other forces throughout the test, and after the completion of the test, recovery teams will retrieve the Crew Dragon from the ocean and send it back to Texas to the SpaceX facility where it will be closely assessed and refurbished. This test is one of the milestones NASA's Commercial Crew Program and SpaceX agreed to as part of a development effort for a privately owned and operated crew transportation system that can safely, reliably, and cost-effectively carry crews to and from low Earth orbit. T-minus 10 minutes and counting. Everything remains go. The terminal sequence auto sequence has been initiated. Everything will be automatic from this point forward. 9 minutes and 40 seconds away from the beginning of the test. This test is being performed under the Commercial Crew Integrated Capability Agreement between SpaceX and NASA, but it can be used for the developmental flight as SpaceX continues on the path to certification. Both SpaceX and Boeing are working under separate commercial crew transportation capability contracts to complete the development of their spacecraft and flight systems ahead of flight tests in 2017 to certify their use in operational flights to the International Space Station. The Dragon Inertial Measurement Unit alignment has begun. This will help guide the spacecraft on its short journey off the launch pad to the Atlantic Ocean this morning. T-minus 8 minutes, 30 seconds and counting. And the inertial measurement unit alignment is complete, just under 8 minutes and counting. T-minus 7 minutes, 30 seconds and counting. Launch Director Kiko Donchev informing the team that weather is go, all systems are go, and we are go for the test at 9 a.m. Eastern Time. T-minus 7 minutes and counting. Dragon has transitioned from battery power to, or from external power to internal battery power, and will remain this way throughout the test. Six minutes, 30 seconds and counting. The propulsion system is about to be pressurized. T-minus 6 minutes and counting. Hypergolic propellants, the monomethyl hydrazine and nitrogen tetroxide, pressurized for the test. The propellant tanks are pressurized and everything remains go. Sea states predicted to be about 5 feet waves. It's within limits for recovery, and there are 3 SpaceX recovery boats on station and ready to make the recovery after today's test. Just under 5 minutes, 30 seconds and counting. T-minus 5 minutes and counting. Latest wind data from Launch Weather Officer Mike McAleenan, 21-knot winds in the area, which is within the 25-knot limit. Everything remains go. T-minus 4 minutes, 30 seconds and counting. T-minus 4 minutes and counting. T-minus 3 minutes, 30 seconds. Everything is go.
Accurate trigger is high. TDOS is recording. Video encoders are on. GoPro camera recording has been triggered.
Recording devices that are in place to document today's test have been activated. High-speed recorders will document every aspect.
Go for launch. This is a transient current on TDOS.
T-minus 3 minutes. Still go for launch.
Cabin fans are off.
ACQD disconnected and gas flow closed out.
These calls are expected. This is per the plan. 2 minutes, 45 seconds and counting. Standing by for a final go for launch.
LD verified. Go for launch.
LD is go for SpaceX pad abort test.
Launch Director Kiko Donchev is go for the pad abort test. Coming up on T-minus 2 minutes. 2 minutes and counting. No technical issues and everything is green on the weather board. Recovery craft on station just offshore from Cape Canaveral Air Force Station in Florida. The Dragon spacecraft at Space Launch Complex 40. T-minus 1 minute and counting.
Dragon is in countdown. T-minus 58 seconds.
Everything remains go. The Dragon and trunk, 20 feet tall as you see them, will lift off. The 8 Super Draco engines will burn for 8 seconds, and the trunk will then detach, fall into the ocean when the spacecraft reaches apogee. The Dragon will deploy drogue chutes, then main chutes, and parachute into the water. The entire test should last about 90
T-minus
seconds.
30 seconds. T-minus 20.
Power deployment is nominal.
15.
T-minus 10,
10.
9,
9.
8,
8.
7, 6, 5, 4, 3, 2, 1.
Launch.
And we have ignition. The Super Dracos have ignited and are pushing the Crew Dragon off the pad.
Burn up. 50 meters per second.
Engines have shut down as planned after about a 5.5 second burn.
Over 1 kilometer.
The trunk has detached.
Trunk deploy.
Dragon is tumbling as planned. The drogue chute has deployed as planned.
Drogues look good.
Drogues look good.
Sequencing the mains. Passing through 600 meters. Downrange distance.
The main parachutes, all three, have opened, gently lowering the Dragon test article to the ocean's surface.
Hang tight, everyone.
One minute into flight.
Dragon is at terminal velocity.
Dragon is at terminal velocity.
Level.
Spacecraft gently being lowered to the Atlantic Ocean.
Avionics level.
Avionics knowledge level.
And we have splashdown. The Crew Dragon test article has splashed down just offshore from Cape Canaveral Air Force Station in Florida. This view from Dragon.
Dragon is in water landing.
Avionics knowledge level.
And the three parachutes.
This concludes the Dragon pad abort test. All stations proceed to recovery operations on launch vehicle net.
Gently lowering into the water. And launch conductor Aaron Beck announced to the team that this concludes the SpaceX pad abort test. This flight test, unlike any seen in Florida since the days of Apollo, with the parachutes floating next to it, the Dragon spacecraft is waiting for two fast boats and a barge to lift it out of the sea, and it will then be brought back to the shore and loaded onto a truck for transport to McGregor, Texas, where it will be inspected, cleaned, and readied for another more demanding flight test planned later this year. SpaceX engineers will pore over the telemetry and other data recorded during today's flight test to evaluate the launch abort system and Super Draco engines. And NASA's Commercial Crew Program experts also will help evaluate the results as the development of one of the new generation of American spacecraft continues on pace. In the coming months, the SpaceX team will put the Crew Dragon through an in-flight abort test that will again put the Super Draco engines and the spacecraft through a simulated emergency. That test will take place on the opposite coast of the United States. It will take place from Vandenberg Air Force Base in California. So with the Dragon having lifted off from Space Launch Complex 40 and splashed down in the Atlantic Ocean, we will conclude our coverage. This is Dragon Test Control.